Hey everyone, we have a special guest today. We have Denis Vrdoljak joining us from Berkeley Data Science Group. Thanks for having the time to have a conversation with us and coming to RetrieveX. Can you give us a brief background about yourself? What are you doing? What are you working on? What are the exciting things that you see?
Yeah, my pleasure. Happy to be here. So we're working on generative AI and classical data science and AI, but we're focusing on customers that are in very data sensitive or regulated industries. So dental, medical, lawyers, legal, some parts of financial, a lot of parts of fintech are not restricted, but some parts are, of course, and government, of course. And so we're bringing the products that we're talking about at this conference, and I assume at the previous interviews, bringing some of those tools and technology and building custom solutions for clients where they have regulatory restrictions or they have very sensitive data that they want to make really sure it doesn't get released, or maybe they don't want it on the cloud.
What are the key challenges that you see when you take this LLMs, large language models, and deploy this on private and sensitive data?
There's two challenges. There's a technical challenge and then there's a practical challenge. The practical challenge is when we're working with a customer, sometimes they have a data scientist or data scientists. Often they're the business decision maker. The understanding of what is an LLM and what is it not. Because you go to ChatGPT and you ask it, like, tell me the difference between cats and dogs as a pet for my apartment. It'll give you a whole explanation of it. If you ask it, why are cats better than dogs, or I like dogs better, why are dogs better than cats?
Me too.
It'll give you a justification for that. So you can ask it leading questions. It's a reasoning engine and a language model, and that's really hard to explain to the business stakeholders and decision makers. They have a little bit of a disconnect between what they've seen that it can do and what it actually does under the hood and what it doesn't do well.
And how do you solve this disconnect? Like they are the reasoning engines, but they also do a lot of mistakes. How do you explain this, that the limitations are and where we are standing in terms of the current state of the art technology?
So when we design something, especially for, usually if it's a data sensitive application, there's also a cost for those mistakes that's maybe higher than like a e-commerce recommender system. So we take that into the design stage. So the architecture and the entire definition of the product, we work very closely with the customer to define the product that fits their use case instead of giving them what we know how to build. So everything that we build is customized to each client. And sometimes it's not a lot of customization because we have modular components we can put together, customize the one that that client needs. But that's how we've addressed it, by being very hands-on, high touch, but also talking to the client to make sure that they understand what they need, and so we understand their use case.
So it looks like you build this compound AI system that you kind of build with building blocks, plug and play, can customize for each customer.
Yeah.
I'm curious, within these components, what is the role of the retrieval system, the AI search, and how is it impacting the rest of the pipeline?
The retrieval system, well, let me answer that a different way. So if you roll back 20 years ago, the old definition at one point of AI was the combination of a reasoning engine and a knowledge base. And AI, machine learning, have been buzzwords in marketing, and they change definitions every 2 years, it seems like. But if you take that old definition, the reasoning engine is the LLM in today's Gen AI, and the knowledge base is not the LLM because it only has enough knowledge. It's meant to be a language model. Yes, it had to learn some facts to be a language model, but to really have a knowledge base, you need a separate source of information. It's something that you can update without having to train a 1.5 trillion weight LLM every couple of weeks. So for the whole system to be practical, you need an external source of knowledge, and to use the LLM as just the thing that turns that knowledge into conversational language.
From the use cases that you work with customers, what is more important, the latency or the accuracy?
In our case, it's been accuracy. The way that we design things for data security sensitive industries is by keeping a human in the loop so that we don't fully automate anything. Like if you imagine a doctor is treating you, they get your x-rays, your chart, and they'll make some recommendations or diagnose you. They might have an AI that gives a second recommendation, but do you want the AI diagnosing you like, oh, you have this condition, you need to go in for surgery, take the doctor out of the loop? That wouldn't work very well. So we keep the human in the loop. So because there's a human in the loop, the latency already doesn't matter as much. And we've actually deployed a dental second opinion software, not one that we wrote, but put it together for a couple of dental offices kind of in that way.
A lot of people say that AI is overhyped. What are the real ROIs that you see for your customers that you deployed into production?
AI is overhyped, and it can make a huge impact on the world. So it's kind of both. The things that people think it can do is overhyped, and the things that it's really good at, that where it can make the world a better place, is not talked about because it's underhyped because it's boring. Like second opinion for a doctor or a dentist, second set of eyes identifying things the doctor or dentist might not pick up on firsthand. Really useful, makes a big difference to the patient. One project that we worked on was with a large law firm. I don't know if you've ever had a lawyer work on a project, even a contract lawyer. You get their invoice and it's like, good luck reading that, making sense of that. Yeah, so we built them a LLM that would rewrite those line items so that they could process it through the LLM, get a more detailed version of it, and then use that either internally or share that with their clients.
There's one last question, like what is keeping you excited for the next 5 years? How do you see this field evolving and your role in this field?
The capabilities of LLMs, especially with multimodal capabilities, are really impressive. They're the reasoning engine. But to make that reasoning engine, especially when you build a product, it'll take you a couple quarters, a couple years to build it. To have it be up to date, you need to have a good external knowledge base, some type of RAG system that keeps the system, the product, relevant. And the way that the capabilities of the LLMs and the different ways of doing RAG, both kind of the traditional vector indexing as well as mixing it with traditional RDBMS types of databases, kind of how they are evolving one next to the other is really interesting. And I think that's where a lot of the future capabilities of LLMs will lie.
Thanks for taking the time and coming to this interview and to the conference.
My pleasure. Thank you for having me.
Great.